a take 20 of this episode.
A lot of brain damage going on, Alex.
Just chaos with all the equipment this morning.
Yeah, but we're back. We're living life, loving it.
I'm going to need a brain scan after this.
Yes. Luckily, that's what we're talking about.
Oh, interesting.
Whoa,
Very interesting transition you have there, sir.
A team for the Center for Translational Research in Neuroimaging and Data Science,
Trends.
leverage deep learning to better understand how mental illness and other disorders affect the brain through brain imaging.
Yeah, so when I take a picture of something, albeit you may be quite uninteresting to take a picture of.
Yeah, we don't want to take a picture.
But there is a lot of data in that image itself.
Mm-hmm.
There's a lot to analyze. Depth, angles, colors, vectors, body positions, pupil dilation. There's just so much going on, right? Albedo off of your skin, maybe you're sweating, all this good stuff. Now, that is so much information that is all essentially not really interconnected. And when you look at a standard machine learning model, it's not really conducive for image analysis. So from a medical standpoint, when you look at MRIs and genome sequencing, when it's taking that sort of snapshot that is so data heavy,
Right.
using a standard machine learning model isn't necessarily the most conducive route for that because we don't know a lot about what we're taking pictures of or the sequencing aspect of human genetics. So if we don't know how to analyze it or where to start or what to look for, regular machine learning doesn't do us any good because we haven't predefined, we want you to look for these sort of correlations. Now, the difference between machine learning and deep learning is that deep learning can efficiently take massive amounts of data and it can analyze it in its complex structures and then figure out what maybe we should be looking at. So rather than us coming in ahead of time and saying, this is what we need to look at, it'll analyze huge amounts of it and then try and see later by working backwards to say, these are kind of the pointers or the key takeaways that we need to look at in this sort of analysis so that when you, as a doctor, come back in, you can say, okay, I can reference what the deep learning model is telling me we should look at, which was otherwise an unknown. And then I can use that and say, okay, now I know what to look for first when I go to do another scan. And I could go back and put that into a machine learning model. But with the deep learning, it helps for figuring out, well, what is the X that we're trying to solve for that we didn't know it needed to be solved for. Does that make sense?
Yeah, no, that makes sense. And one of the things that they talk about is, and they talk about this in the article, conclusions are often based on pre-processed input.
Yeah.
That deny deep learning the ability to learn from data with little to no pre-processing. One of the main advantages of the technology. So pre-processing seems to be the key.
Yeah, when pre-processing is a function that we're doing for machine learning in most standard models. And that's why a lot of people have a preference for it because it's quite quick and it can handle pretty big data sets. But anything like supermassive requires that deep learning and it doesn't require that pre-processing or saying this is what you need to look for. It can actually go back. And so not only do you have some sort of analysis and output that you're receiving from the deep learning, but you can also go back and say, oh, okay, what is the algorithm it decided to use after deductively going back? And then you can say, oh, that's quite interesting. And then you can also test that specifically. And maybe you can take that, oh, great, you learned this algorithm. Now let me take that and go put it over into a regular machine learning model.
Yeah, and I liked how they were talking about, like a classical machine learning paired to deep learning with like single number measurements. Mm-hmm. Classical machine learning works better, like patients' body temperatures or patients that smoke cigarettes. Those approaches work better because you're analyzing something that is more linear.
Yeah, it's linear. It's a very binary world. It's up or down.
Like taking 5 million patients that you have in this healthcare systems and then analyzing their temperatures that they're coming into the emergency room on.
Yeah,
a classical machine model would be fine that way.
It'd be fine.
It would work more efficiently.
But then you start doing where you're imaging a three-dimensional brain.
Mm-hmm.
Think about all those different vectors and all the angles you have to analyze it at and say, oh, did I miss it somewhere else? Deep learning is more conducive for something like that.
Yeah, complex information.
Yeah.
And then they were saying, what this is what was interesting. I mean, they were saying that they could analyze complex information, and then it does a better job of answering simple questions. So would classical machine learning have an issue? We're answering a simple question. Is it going to confuse it, or does deep learning understand that you're asking a simple question?
No, I think deep learning has a better job of understanding after the fact of the simple question being asked.
Yes, yeah.
It all goes back to that sort of pre-processing. Who puts in the input? And you better hope that your deep learning model is not like racist or anything like that.
Yeah,
what if it's like, oh, interesting, but who knows what that.
Well, this gets into and I thought this was really interesting.
Yeah.
You're going to love this part. Another advantage of deep learning is that scientists can reverse analyze deep learning models to understand how they reach conclusions about data. So you can have a deep learning machine checking out. I mean, I imagine they have it checking out the classical machine.
Why not?
And then have it reverse engineering and seeing what's happening.
It's like a good psychiatrist, right? You want to kind of break it down over time, and it's like, well, how did you come to that? How did you come to that conclusion?
Well, I mean, it's they're learning on their own. So I want to know. I want to know what love is.
They're not learning. They're deducing. There's no learning being made. If it was learning, then it would be able to think, deduce, and then act again upon this,
right?
Completely on its own free will. We start and stop this machine. I'm tired of hearing that these things learn. They're not learning. They're deducing. It's like a really good Sherlock Holmes.
Yeah, but they're finding things that's outside of maybe what a human would deduce.
Well, yeah, that's the point.
So then it's like, oh, why is it coming to this conclusion? And then from
beneficial.
There,
that's the beneficial part.
And they said this: we can check the data points a model is analyzing and compare it to the literature to see what the model has found outside of where we told it to look. Yeah,
that's what I was saying. So if doctors are only looking in one place, the group can miss something.
Right.
And this will be like, hey, you missed something. You know how we can become blind to this world and certain truths if we have a warped perspective? This thing's coming in, it's just like, I'm going to analyze it. Right. I don't care how you think about the world or whatever it might be. I'm just going to look at what's here and then derive some sort of output.
Yeah, and there was a article that was published in Nature Medicine that demonstrated deep learning's potential. And I think this is the key word. Is they're looking at potential, yes. Yeah. Do you want to talk about that?
Yeah, you're correct. Keep going.
So, our results point to the clinical utility of AI for mammography in facilitating early breast cancer detection, as well as an ability to develop AI with similar benefits for other medical imaging applications. We have developed an approach that mimics how humans often learn by progressively training the AI models on more difficult tasks.
Yeah. So it's like, great, you've learned how to deduce over here with the least amount of error. Let's open you up to something more difficult.
Yeah, and that the AI can detect cancer accurately while also relying less on highly annotated data. Our approach and validation extend to 3D mammography, which is particularly important given its growing use and the challenges it presents to AI.
Yeah, I don't want anything anecdotal. I want to know specifically what's going on here, directly related to that patient. And if this thing can do a scan, deep learn, and within the hour tell the person like, hey, these cells don't look good. Yes. Or this actually looks like a malignant brain tumor. We got to work on this right now. Even if the doctors are looking at it and you got 5 of them staring at like an X-ray or the MRI, like, maybe. And this thing's, well, I know you guys are waffling on it, but to us, this looks really bad because we've scanned thousands of brains. I've deduced over all of them. We know what the error rates are, and I put this back in. This probably looks like something we should deal with.
Yeah, and so right now it's not used in real-world clinical settings, but the technology is going to be the future of care.
Yeah, I think that's phenomenal. If we can start scanning people and bodies and genome sequences and have these things learn from it very quickly, and we can bring someone to a better quality of life and state of health faster, let's do it. And if we can just, in Amazon or some stores, I can walk in, it's got RFID, and I walk out of the store and it charges me. Why can't I just walk through a scanner at the hospital and it says, you're good to go. See you later. Mm-hmm. I don't have to see a doctor, nothing. It scans me, and it's a very proactive approach. Once a month, you go through a scanner, bye.
Oh, that would eliminate so much. If you I'm not really feeling that well. Let me go in this booth and have it scan me real quick.
You go in,
the future.
Mouth gets swabbed. Yeah. It goes through a genome sequencing thing. Yeah. Goes through that, and it also does a full body scan. Bye.
You got the flu.
Okay, bye.
Next, yeah,
See ya.
here's your medicine. Get out.
And you got like a machine that outputs the thing. Here's your stuff, and then boop, it pops the pills out right there.
Yeah, perfect. That's how it's going to be.
Oh, that's our new hospital.
We love it.
See you later.
The future predicted here at TCast.
Just like Alex Jones. I talked about this. We were the ones.
Now you just screwed up the algorithm. You can't talk about Alex Jones and you can't talk about COVID.
Google's going to take us off because we were rapping on Alex Jones. Sorry about that.
We hate Alex Jones.
Oh, yeah, we didn't mean to say that.
Google, we hate Alex Jones. And
it's like, I don't care what
get
you
your
say.
COVID vaccine. What else? Go see a doctor.
Yeah.
This is not medical information.
Globalism is good. Underground bunkers, you don't need them.
Yeah, exactly. Okay, perfect. We're out.
Yeah, bye.